it would detonate and obliterate all of New York City, parts of Connecticut, and New Jersey. This is quite possibly one of the best secrets in our material science. Betelgeuse, a divine miracle gracing the night sky, is a famous red supergiant monster settled in the Orion star grouping, dazzling stargazers for ages. Later, refreshes from eminent physicist Michio Kaku have raised concerns, proposing that Betelgeuse might have at last detonated. How this blast reshapes our comprehension of stellar life cycles and the powers molding our universe is a question of incredible importance. What suggestions does it hold for us? Stay tuned to find out. Envision looking at the night sky and recognizing a splendid star in the Orion heavenly body. Betelgeuse, otherwise called Alpha Orionis, is a huge heavenly body at roughly 5 hours 30 minutes right ascension and 0 declination. It infers its name from the Arabic word Bat al-Azra, meaning the monster's shoulder. In 1603, cosmologist Johann Bayer gave the star its extraordinary name Alpha Orionis, implying its status as the most splendid star in the Orion star grouping. Strangely, despite being perceived as the most splendid in Orion, Betelgeuse holds its name proudly. Betelgeuse is a giant star with a mass multiple times more noteworthy than our Sun, making it a giant contrasted with our planetary group. To place it in perspective, on the off chance that the Sun were a little marble, Betelgeuse would be a tremendous ball. Determining Betelgeuse's distance has been challenging, with gauges setting it somewhere in the range of 500 and 600 light-years from our Sun, a tremendous distance in cosmology. As far as splendor, Betelgeuse sparkles brilliantly with a really splendid rating of around 6. Harvard College analyst Morgan McLeod noticed that Betelgeuse's closeness and size make it one of the few stars researchers can closely inspect using telescopes on Earth and in space. Telescope pictures reveal Betelgeuse's unique elements, exhibiting a surface unmistakable from our Sun's smooth appearance. Rather than a uniform circle of incredibly hot plasma, Betelgeuse shows up as an assortment of lopsided bubbling gas pockets, some practically identical in size to little stars. Significant eruptions of hot material arise from Betelgeuse's center to the surface, resembling astronomical spring cleaning. One such shell is gigantic to the point that traveling at the speed of light would take 75 years to cross. This cycle, known as surface mass discharge, spews materials from Betelgeuse's external layers like the Sun's coronal mass discharges. Notwithstanding varying inward designs and processes, Betelgeuse, at a mere 10 million years of age, is astoundingly youthful contrasted with our Sun. In spite of its youth, Betelgeuse has already depleted the hydrogen fuel in its center, entering the later phases of its existence as it transitions into the red supergiant stage. During this stage, Betelgeuse uses helium to create carbon through fusion processes, displaying a fast transformative excursion fueled by its significant introductory mass. Upon entering the world, researchers suggest Betelgeuse began its grandiose excursion as a blue-white type star, belonging to the most monstrous classification of hydrogen-consuming main-sequence stars. In the domain of stars, size straightforwardly connects with splendor and extreme intensity. Larger stars like Betelgeuse shine more brightly and consume more hotly. Yet this also leads to quicker hydrogen utilization and an earlier progression to the red giant stage. Betelgeuse's surface reaches staggering temperatures of up to 89,500 degrees Fahrenheit, a sharp difference to our Sun's lukewarm 10,000 degrees Fahrenheit. As Betelgeuse consumed its hydrogen and began intertwining helium, its external layer expanded fundamentally, making it quite possibly one of the largest stars we know, extending more than 700 million miles in diameter. By now, Betelgeuse's surface temperature is around 5,800 degrees Fahrenheit, cooler than the Sun, yet it dominates the Sun by a noteworthy 7,500 to 14 times. In 1836, stargazer John Herschel noticed changes in Betelgeuse's brilliance, prompting its classification as a semi-regular variable star with intermittent changes and periodic unpredictable variations, commonly following a multi-day cycle. In 2019, Betelgeuse displayed a peculiarity, deviating from its typical behavior. Betelgeuse's recent lead garnered attention due to unusual changes. Generally, its radiance wavered following a consistent 400-day pattern, lighting up to a magnitude of 1.3 and then diminishing to around 2.8. These vacillations were related to the external layer called the photosphere, which transmits the majority of the star's light and heat. Convective movement in the photosphere, where heat moves from the inside to the surface through gases, causes variations in splendor over time. During the autumn of 2019, Betelgeuse experienced significant diminishing by roughly 60%, marking a deviation from its standard pattern. The cause was a monstrous discharge of material, forming a broad dust cloud that clouded our immediate view. Although the dust cloud has scattered, Betelgeuse hasn't completely returned to its previous state, and its 400-day brilliance cycle has abbreviated to only 200 days. Betelgeuse's capricious behavior has sparked discussions about the potential for an upcoming supernova explosion. In a supernova, as the star consumes its remaining fuel, its center collapses, giving rise to a black hole while simultaneously ejecting outer layers at velocities of up to 25,000 kilometers per second. If Betelgeuse undergoes a supernova explosion, it would be a stunning display, visible for several weeks, much like the full moon, due to its proximity of only 650 light-years. While star explosions are common, they're often too far away to be seen without powerful telescopes, making Betelgeuse's potential supernova a striking event for night sky observers. As stars evolve, their centers gather iron, ultimately triggering a supernova. The latest identifiable supernova, SN 1987A, occurred in 1987, around 168,000 light-years away. This event was visible to the unaided eye and provided significant insights into stellar evolution. The last recorded supernova before that, recorded by Johannes Kepler in 1604, eclipsed all other stars in the sky, even during the day, yet had no tremendous consequences for Earth due to its significant distance. Betelgeuse, a star at the center of attention, is supposed to undergo a supernova, and Miguel Monteros, a Betelgeuse expert, expects its brightness to equal that of the full moon when the supernova moment occurs. Picture a hypnotizing 2-month stretch where, on a starry night in a dark city, you could read a book washed in the glow of Betelgeuse's supernova. In 2021, Betelgeuse experienced a dimming event similar to the 2019 peculiarity, with around a 60% reduction in brightness attributed to the presence of a cloud within the star's wind. This cloud obscured part of the star, causing a missing southern hemisphere in images. Following this dimming event, Betelgeuse unexpectedly increased in brightness by half. The reason for this surge remains unclear, prompting speculation among cosmologists. Betelgeuse, currently 15 to multiple times the size of the Sun, falls into the category of stars expected to undergo a supernova. Astronomers generally suggest that Betelgeuse could explode within the next 100,000 years. However, a new study by Hayuki Cio and associates from Tohoku University proposes it may be in a further developed stage, closer to detonating. However, there are varying opinions on the validity of this conclusion. Cio's group bases their statement on Betelgeuse's throbbing behavior, consistently expanding and contracting with overlapping hints. While they don't predict an inevitable explosion, they suggest it could occur within the next 1,000 years, challenging the longer timescales previously considered. The uncertainty surrounding Betelgeuse's timeline has captured the interest of cosmologists. However, some researchers argue that stars like Betelgeuse can endure for more than 10 million years, a shockingly short range for astronomers but surprisingly extensive for those outside the astronomical domain. As they search for hints about whether the brilliant star could become a supernova, cosmologists note changes in the star's color in old compositions. Individuals describe the star's tone as akin to Saturn's yellowish hue, not Mars' ruddy tint. This raises the question, has the star's color changed? If so, it could indicate rapid evolution, suggesting a supernova could occur sooner than anticipated. This color shift offers a sign about the star's changes, aiding researchers in interpreting cosmic events. Whether Betelgeuse undergoes this explosion on time or takes its time to give a heavenly show, humanity will have a front-row view to observe the confirmation of amazing cosmic phenomena. What might occur if Betelgeuse went supernova? The prospect of a supernova appearing in our sky has captivated people's imaginations. New simulations assist cosmologists in understanding what we could see when Betelgeuse eventually detonates, expected within the next 100,000 years. However, uncertainty remains. Betelgeuse is around 500 light-years away, and recent research suggests a significant star must be within about 150 light-years to cause perceptible effects. Around 26 million years ago, an event of this nature may have played a role in a termination event affecting marine life after the Permian extinction. If a supernova occurred in our region closer than 30 light-years, things could get uncertain. Although Betelgeuse's supernova isn't anticipated to threaten life on Earth, there could still be some atmospheric effects. The explosion would produce a surge of ultraviolet radiation, potentially leading to a brief reduction in the ozone layer. However, research shows any subsequent ozone depletion would likely be minor and brief, with limited ecological ramifications. Shortly after the explosion, we would identify weightless particles called neutrinos, which are harmless to us. The star would quickly become brighter, reaching a luminosity similar to the full moon within a matter of weeks. Betelgeuse's brightness would then wane over time, gracing our daylight hours for around half a year to a full year. As night descends, it would continue to be a prominent display for another 1 to 2 years before bidding us a final farewell. Tragically, Orion would forever lose its red shimmer, a glow etched into memory. Regarding the danger to humanity, supernovae produce strong particles known as cosmic rays, which can penetrate Earth's magnetic shield. However, except for the nearest supernovae, the amounts would be generally minor compared to other radiation we experience. The supernova's stunning finale wouldn't just mesmerize us. It would also create radioactive iron, an immense signature found in Earth's seafloor and even gracing the moon. This iron, born from a supernova that impacted 2 to 3 million years ago, was a mere 300 light-years from us. Luckily, its proximity posed no significant danger to life on Earth. Rest assured, such a nearby cosmic explosion is an extraordinary case, potentially occurring only once in a billion years. As speculation surrounded the potential appearance of a Betelgeuse supernova, space expert Andy Howell from the University of California was not satisfied with simple back-of-the-envelope estimations. Seeking accuracy, he enlisted the help of 2 ex-graduate students, Jared Goldberg and Evan Grove. Their intricate simulations distinctly depict the star's epic finale, acknowledging uncertainties while using insights from observations of supernova SN 1987A, the closest recorded instance of a star's cataclysmic end in recent centuries. These cosmologists concluded that life on Earth would remain unscathed. However, the astronomical landscape will not go unnoticed. According to Goldberg and Grove's findings, when Betelgeuse ignites, its brilliance will resemble the soft glow of a half-moon, shining roughly 6 times fainter than the brightness of a full moon. This mesmerizing luminosity is projected to grace the skies for over 90 days. Recent studies demonstrate that Betelgeuse is around 724 light-years from us, safely outside the expected risk zone. Nonetheless, the supernova could have fascinating implications for Earth. Howell highlights that many creatures depend on the moon for navigation and might be bewildered by extra bright objects. Astronomers themselves would face challenges, as the intense brightness would surpass the capabilities of telescopes and space observatories. To adapt, telescopes would need to capture the subtler, gentler glow. Experts assure the public that there will be ample warning if Betelgeuse goes supernova during our lifetimes. Earth's instruments would detect signals like neutrinos or gravitational waves generated by the blast, giving us a heads-up as much as a day prior to the event. Although this occurrence isn't likely to happen for another 100,000 years, Betelgeuse will ultimately become a supernova, and the aftermath depends on the materials that remain after the grand finale. We anticipate Betelgeuse's potential supernova as researchers continue to refine their predictions and improve their understanding of such celestial phenomena. Observations of comparable stars in various phases of their development provide essential data for modeling the life cycles and possible explosive endings of massive stars. This information assists astronomers in assessing the frequency and impact of supernovae within our universe, contributing to our broader understanding of cosmic events and their implications for both nearby and distant celestial bodies. The study of Betelgeuse and other supergiants also aids in calibrating cosmic distance scales. Accurate measurements of such stars' brightness and behavior help refine the methods used to determine distances to far-off worlds, thus improving our overall mapping of the universe. Furthermore, Supernovae serve as invaluable probes for understanding the synthesis and distribution of heavy elements like iron and nickel throughout the universe. These elements play a significant role in the formation of planets and life as we know it. In the meantime, space observatories are closely monitoring Betelgeuse and similar stars, utilizing cutting-edge technology to detect any signs of impending change. These efforts ensure that we are prepared to observe and study one of the most dramatic events in the universe's life cycle, enhancing our knowledge of the dynamic processes that shape the cosmos.